Module 25, Non-Parametric Tests, Section 2, Kruskal Wallis Test and Spearman's Rank Correlation Test. Kruskal Wallis Test, which is analogous to ANOVA, one-way ANOVA, which I already explained to you earlier. So, Kruskal Wallis test, what are the hypotheses here? The null hypothesis is that the population medians are equal, while the alternative hypothesis is that the population medians are not equal. And this test is based upon median. Remember, the ANOVA is about the mean, but here it is all about the median. So it is something like the Wilcoxon signed rank test, which we explained in the last section. This is also based upon Kruskal Wallis is also based upon the medians. Assumptions are one independent variable with two or more groups. So there are more than two groups here. So for two you have to you may consider using a Mann-Whitney U test, which I already explained in the last section. Measured dependent variable, the measured variable has to be it is basically, it has to come from ordinal, interval or ratio scale, not from the nominal scale. And observations have to be independent. All groups should have the same shape distribution. That is yet another assumption for this test to be fine. So the H test statistic is also calculated from the ranks, and the equation is quite familiar by now. It's almost identical to the way which we did it for Mann-Whitney U test. So same way, it's all the group. We have to assign the ranks based upon the overall rank. Then you can plug into this equation to calculate this one. So it's 12 divided by n multiplied by n plus 1 sigma Ti divided by Ni. So Ti squared divided by Ni minus 3 multiplied by n minus 1. So what are these values here? N means sum of sample sizes for all sample. The overall sample size is n. While C means number of samples. Sometimes it is also represented by the letter K. So number of samples or number of groups, or C. It is basically number of groups basically. Ti or Tj is sum of ranks in the jth sample. Basically in one group, what is the rank? The total sum of that rank is Tj. While Nj is the size of the sample. So sample size means the group, how many elements are there in that group, that is Nj. You can do this in a freely available online calculator, which I linked up in the site, or you can do that manually as well if you are intuitive to know how the test works, which is quite similar to the Mann-Whitney U test, but here it is basically for more than two groups. And then you can the stepwise calculation is also there, and H test statistic is there. Now once you have the H statistic, you have to find that in your the H from the critical value from the table. So here for this test, the table, there is no special table for Kruskal Wallis. So there are tables, but you don't really have to look up that. Here a good approximation is chi-square distribution table. So you can simply look the chi-square for finding the critical chi-square, and you can compare that with H which we found in the test. Because Kruskal Wallis test distribution is one good approximation is a chi-square distribution, so that is the thing. So if the calculated value of the Kruskal Wallis test is less than the critical chi-square value, then the null hypothesis cannot be rejected. So the interpretation is just like any other test, not like the earlier non-parametric test like Mann-Whitney U test, So if the table value is less than the test value, p-value must be less than 0.05 and the results are significant. So here, as you can see, 7.815 is the table value, which is in fact less than 16.55, which is the test value, and therefore p-value must be less than 0.05 and the results are significant. Coming next is Spearman's rank correlation, which is it is just like the Pearson's correlation test. But here, this one, the Spearman's correlation is based upon the ranks. That is the only difference here, which is quite analogous to the Pearson's correlation, which we covered in module number 22. So here the correlation coefficient is something called rho, RH or rho. So rho is basically 1 minus 6 sigma d square divided by n cube minus n. So this is the formula for Spearman's rank correlation. So here Rs is Spearman's correlation coefficient, or also known as Spearman's rho. D is the difference between the ranks, and n is the sample size. So the formula is very simple and intuitive, and you can easily do that using a paper and a pen. So the hypothesis is that the Spearman's constant, that is Spearman's coefficient, that is rho, is equal to 0. That means ranks of one variable do not covary with the ranks of other variables. See, it's not that the raw scores of the variable is covarying or not. It's only about the ranks of this variable covarying or not. So alternative hypothesis is that the rho is not equal to 0. So it is a two-tailed test. It could be less than 0 or it could be greater than 0. Assumptions are, the scale of measurement must be ordinal or interval or ratio, not nominal. Data must be in the form of matched pairs, and the association must be monotonic. Matched pair is, of course, there is the same assumption for Pearson's correlation test as well. So each value should be from x and y. So both the variable has to be matching in each of these data points, and association must be monotonic. So that means that increasing together, right? That is what the monotonic means. Or of course it's decreasing together is also monotonic, but increase and decrease, that is not a monotonic functional. So let us consider the same example which we discussed for calculating the Pearson's correlation in module number 22. It is x we have, y we have. The next step is that we have to provide the ranks, the overall ranks of these two things. So x rank and y rank. So you put the ranks of this one. And finally D, you can calculate the D. So that basically the D means the difference between x and y. So x rank minus y rank is the D. Then next column will be D squared, simple, and finally you calculate the sum of all D square value. So that is how to calculate the Spearman's coefficient. Now you have got this D square, sum of D square, and you can just put into this formula here, that is Rs is equal to 1 minus 6 sigma D square. So sigma D square, which we calculated on the spreadsheet, divided by n cube minus n. So n is the total number of elements of this the table. So here, as you can see, that n is 13 because we have 13 elements in this here, and the solution is also provided here. You are going to get a solution 0.75, that is the rho, Spearman's rho, which indicates significant positive correlation between these two factors. And the same thing which you can use in an online calculator, I have already linked up in the site. So online calculator also has got similar the Spearman's rho value. So and the online calculator, one advantage is that it can also calculate the exact p value, and here you can see the exact p value is much lesser than 0.05, and that means that the results are significant. Well, there are other kinds of non-parametric tests that analyze the values. It's not really analyzing the rank, but exactly the values. These tests are empirical values. These are based on the empirical values, not the rank. So from one small sample, millions of pseudo replicate samples can be formed. So these are something called computer intensive method. So for example, if you have a small sample of for example 8, you can make this resampling of the same thing again and again to make millions of samples, so that way you can do that way. So how does it work? Well, a simple intuitive analogy is that, these sample, you simply mark or label these sample as A, B, C, D, E, F, G, H, something like that, and put all these labels in an index card to a small bucket, and simply draw one card, note the value, put it back, again mix, again value, so that way sometimes the repetition is allowed and you are making a subset with the repetitions allowed. That is what the first pseudo sample. Second pseudo sample, likewise you can go up to million pseudo sample, and you can work on these million pseudo samples to get the the data done. So randomization test is another synonym for this computer intensive method, and permutation test is also yet another kind of non-parametric test. that is also very useful across the sciences. So in summary, the Kruskal Wallis test is used to compare more than two independent group medians, which is analogous to one-way ANOVA. Spearman's rank correlation test is used to correlate two variables, which is analogous to the Pearson's correlation. Thank you for watching.